multiple choice questions on inverse trigonometric functions. Question number 1. Tan inverse x plus tan inverse y plus tan inverse z is equal to, and the options are, and the correct option is, but before that let's explain it. Sum of two tan inverse functions is given by tan inverse x plus tan inverse y is equal to tan inverse x plus y over 1 minus xy. We add tan inverse z on both sides and apply the same formula for sum of two inverse tangent functions and on RHS, and we get tan inverse a plus b over 1 minus ab. On simplifying, we get tan inverse x plus y plus z minus xyz over 1 minus xy minus yz minus zx. Therefore, correct option is option A. Question number 2. The reference angle lies in the quadrant, and the options are, the correct option is, but before that let's explain it. We know that the angles in first quadrant are taken as reference angles. So the correct option is option C. Question number 3. If cos x is equal to minus square root of 3 over 2, the reference angle is, and the options are, and the correct option is, but before that let's explain it. As we know that reference angle lies in first quadrant, so we take the system to the first quadrant. As all the trigonometric functions are positive in the first quadrant, so we leave out minus sign and get cos x is equal to uh, square root of 3 by 2. From here we get the value of x to be pi by 6, which is in first quadrant. Therefore, correct option is option B. Question number 4. If cos inverse x plus cos inverse y is equal to pi by 2, then sin inverse x plus sin inverse y is equal to, and the options are, let's find out which one is the correct option. But before that, let's explain it. According to sum of inverse complementary angles, cos inverse minus x is equal to pi by 2 minus sin inverse x. Similarly, cos inverse y is equal to pi by 2 minus sin inverse y. So we are given cos inverse x plus cos inverse y is equal to pi by 2. Here we shall replace the values of cos inverse x and cos inverse y, and we get pi by 2 minus sin inverse x plus pi by 2 minus sin inverse x. Here cos inverse x has been replaced by pi by 2 minus sin inverse x. Cos inverse y has been replaced by pi by 2 minus sin inverse y. Here we shall cancel out pi by 2 with pi by 2 and take sin inverse x and sin inverse y to the right side, and we get sin inverse x plus sin inverse y is equal to pi by 2. Therefore, correct option is option D. Question number 5. The number of solutions of tangent x is equal to minus 1 or, and the options are. Let's find out which one is the correct option, but before that let's explain it. As we know that a trigonometric equation has infinite number of solutions, therefore the correct option is option D. Question number 6. Tan inverse x plus cotangent inverse x is equal to, and the options are. Let's find out which one is the correct option, but before that let's explain it. We know that tan inverse x is equal to pi by 2 minus cotangent inverse x, the sum of complementary inverse functions. We transpose cotangent inverse x to right, and we get tan inverse x plus cotangent inverse x is equal to pi by 2. Therefore, correct option is option C. Question number 7. Cos inverse minus 1 by 2 is equal to, and the options are. Let's find out which one is the correct option. But before that, let's explain it. we put y is equal to cos inverse minus 1 by 2, it gives cos y is equal to minus 1 by 2. Now first we assess the reference angle from this relation. We take the system to the first quadrant and we get cos y is equal to 1 by 2, which gives y is equal to pi by 3. Now here the value of cos y is negative, and we know that the domain of principal cos function is from 0 to pi. That is, angle can be in first quadrant or second quadrant. Here the value of cos is negative, therefore angle will be in quadrant 2. Therefore in quadrant 2 we write the angle as pi minus a reference angle. Therefore y will be equal to pi minus pi by 3, which is the reference angle. On simplifying we get y is equal to 2 pi by 3. Therefore the correct option is option A. Question number 8. Tan inverse 3 plus tan inverse 2 is equal to, and the options are, let's find out which one is the correct option, but before that let's explain it. Here we notice that A is equal to 3, which is positive, and B is equal to 2, which is also positive. Also we have the product AB is equal to 6, which is greater than 1. So the sum of two tangent inverse functions will be equal to pi plus tan inverse a plus b over 1 minus ab. In this case, the tan inverse a plus tan inverse b will be equal to pi plus tan inverse a plus b over 1 minus ab. We replace the values of a by 3 and b by 2 and we get tan inverse 3 plus tan inverse 2 is equal to pi plus tan inverse 3 plus 2 over 1 minus 3 into 2. On simplifying, we get pi plus tan inverse minus 1. Now tan inverse minus 1 is equal to minus pi by 4. Therefore, we get the right hand side to be pi plus minus pi by 4. On simplifying, we get the angle to be 3 pi by 4. Therefore, correct option is option B. Question number 9. If cos of a plus 15 degree is equal to sine 60 degree, then cos of 6a is equal to, and the options are. Let's find out which one is the correct option. But before that, let's explain it. Here, cos of a plus 15 degree is equal to sine 60 degree. We write sine 60 degree as sine 90 degree minus 30 degree. Also, we know that sine of 90 degrees minus theta is equal to cos theta. Therefore, sine of 90 degrees minus 30 degrees will be equal to cos of 30 degrees. So we get cos of a plus 15 degrees is equal to cos 30 degrees, which gives a plus 15 degrees is equal to 30 degrees, and it gives a is equal to 15 degrees. Now cos 6a will be equal to cos 6 into 15 degrees. Here we have replaced the value of a by 15 degree. So cos 6a will be equal to cos 90 degree, and the value of cos 90 is 0. Therefore, the correct option is option D. Question number 10. The domain of sine inverse 2x is, and the options are. Let's find out which one is the correct option. But before that, let's explain it. We put sine inverse x 2x is equal to capital A, and we get 2x is equal to sine of A. As we know that the range of sine function is from minus 1 to plus 1, therefore sine A will be greater or equal to minus 1 and less or equal to 1. Now we replace the value of sine A with 2x and we get 2x is greater or equal to minus 1, less or equal to 1. We divide this expression by 2 and get x greater or equal to minus 1 by 2 and less or equal to 1 by 2. Therefore, the domain of sine inverse x, sine inverse 2x will be the closed interval from minus 1 by 2 to plus 1 by 2. Therefore, correct option is option C. Question number 11. Tan inverse 2a over 1 minus a square is equal to, and the options are. Let's find out which one is the correct option. But before that, let's explain it. According to sum of two tangent inverse functions, tan inverse a plus tan inverse b is equal to tan inverse a plus b over 1 minus ab. We replace b with a in this expression. So we get tan inverse a plus tan inverse a is equal to tan inverse a plus a over 1 minus a into a. Here b has been replaced with a. On simplifying, we get 2 tan inverse a is equal to tan inverse 2a over 1 minus a square. Therefore, correct option is option A. Question number 12. The value of sine of cos inverse minus a square root of 3 over 2 is, and the options are. Let's find out which one is the correct option. But before that, let's explain it. We put cos inverse minus a square root of 3 by 2 is equal to a, and it gives cos of a is equal to minus square root of 3 by 2. We know that the domain of principal cosine function is from 0 to pi. That is, angle can be in first quadrant or second quadrant. Here the value of cos is negative, therefore angle will be in second quadrant, and in second quadrant the angle is written as pi minus reference angle. So we can write a is equal to pi minus pi by 6. Here pi by 6 is the reference angle, which can be obtained by taking the given system cos of a is equal to minus square root of 3 by 2 into first quadrant, and we will get the reference angle to be pi by 6. It gives a is equal to 5 pi by 6 on simplifying. Therefore, the value of sine of cos inverse minus square root of 3 by 2 is equal to sine of a. Now we replace the value of a by 5 pi by 6, and we get the expression to be sine 5 pi by 6, and the value of sine pi by 5 pi by 6 is equal to 1 by 2. Therefore, correct option is option A. Question number 13. The domain of cos inverse x by 2 is, and the options are. Let's find out which one is the correct option. But before this, we explain it. Uh, we put cos inverse x over 2 is equal to a, and it gives cos of a is equal to x by 2. And we know that the range of cos of a is from minus 1 to plus 1. Therefore, cos of a will be greater or equal to minus 1 and less or equal to 1. Now we replace the value of cos of a, and we get x by 2 is greater or equal to minus 1 and less or equal to 1. Here cos of a has been replaced by x by 2. We multiply this expression by 2, and we get x greater or equal to minus 2 less or equal to 2. Therefore, the domain of cos inverse x by 2 is the closed interval from minus 2 to plus 2. Therefore, correct option is option A. Question number 14. The value of sine inverse sine of 4 pi by 3 is, and the options are. Let's find out which one is the correct option. But before that, let's explain it. Uh, we know that sine inverse of sine of x is equal to x only if x is in the closed interval from minus pi by 2 to plus pi by 2. But here the angle is 4 pi by 3, which is not in this domain. So we make necessary adjustments, and we write sine inverse sine of 4 pi by 3. Now 4 pi by 3 has been splitted as pi plus pi by 3. We know that sine of pi plus theta is equal to minus sine theta. So sine of pi plus pi by 3 will be equal to sine minus sine of pi by 3. Therefore, sine of pi plus pi by 3 will be equal to minus sine pi by 3. The value of sine pi by 3 is square root of 3 by 2. Therefore, we get sine inverse minus square root of 3 by 2, and it gives angle to be minus pi by 3. Therefore, correct option is option B. Question number 15. Sine of x whole inverse is equal to, and the options are, let's find out which one is the correct option. But before that, let's explain it. Now, we know that sine of x whole inverse is equal to 1 over sine of x, and 1 over sine of x is equal to cosecant x. Therefore, the correct option is option C. Question number 16. If A is negative, B is negative, and the product AB is greater than 1, then tan inverse A plus tan inverse B is equal to. And the options are, let's find out which one is the correct option. But before that, let's explain it. Here A is negative, B is negative, and AB is greater than 1. So according to the sum of two tan inverse functions, tan inverse A plus tan inverse B will be equal to minus pi plus tan inverse A plus B over 1 minus AB. Therefore, the correct option is option C. Question number 17. If A is positive, B is positive, and the product AB is greater than 1, then tan inverse A plus tan inverse B is equal to, and the options are, let's find out which one is the correct option. Here, A is positive, B is positive, and the product AB is greater than 1. Therefore, according to sum of two tan inverse functions, tan inverse A plus tan inverse B will be equal to pi plus tan inverse A plus B over 1 minus AB. Therefore, correct option is option A. Question number 18. 3 tan inverse x is equal to, and the options are, let's find out which one is the correct option. Uh, but before that, let's explain it. As we know that 2 tan inverse x is equal to tan inverse 2x over 1 minus x square, we add another tan inverse x on both sides and apply the sum of two trigonometric functions formula on RHS, and after applying this we get 2 tan inverse x plus tan inverse x is equal to tan inverse 2x over 1 minus x square plus x over 1 minus 2x over 1 minus x square into x. And after simplifying, we get 3 tan inverse x is equal to tan inverse 3x minus x cube over 1 minus 3x square. Therefore, correct option is option D. Question number 19. Cotangent inverse minus x is equal to, and the options are, let's find out which one is the correct option. But before that, let's explain it. Put y is equal to cotangent inverse minus x. It gives cotangent y is equal to minus x, and it gives minus cotangent y is equal to x. We know that minus cotangent y is equal to cotangent of pi minus y. So we can write cotangent pi minus y is equal to x, and it gives pi minus y is equal to cotangent inverse x. Now we shift cotangent inverse x on left hand side and y on right hand side, and we get pi minus cotangent inverse x is equal to y. Now we replace the value of y and get pi minus cotangent inverse x is equal to cotangent inverse minus x. Therefore, correct option is option C. Question number 20. Sine inverse of sine of x is equal to x if, and the options are, let's find out which one is the correct option. But before that, let's explain it. According to definition, sine inverse sine of x is equal to x only if x is greater or equal to minus pi by 2, less or equal to pi by 2. Therefore, correct option is option A. Question number 21. Sine inverse 1 over x is equal to, and the options are, let's find out which one is the correct option. But before that, let's explain it. Put sine inverse 1 over x is equal to y. It gives 1 over x is equal to sine y, and it gives x is equal to 1 over sine y, and it gives x is equal to cosecant y. So cosecant inverse x will be equal to y. Therefore, correct option is option B. Question number 22. Cos inverse 3 over 5 is equal to, and the options are, let's find out which one is the correct option. But before that, we explain it. Here we put cos inverse 3 over 5 is equal to y. It gives cos y is equal to 3 over 5. Now we know that cos square y plus sin square y is equal to 1. So sin square y will be equal to 1 minus cos square y. Replace the value of cos y to be 3 over 5. And after simplifying, we get sin square y is equal to 16 over 25. And it gives sin y is equal to 4 over 5, which gives y is equal to sine inverse 4 over 5. Therefore, correct option is option C. Question number 23. Sine of x is equal to 0, then x is equal to, and the options are. Let's find out which one is the correct option. But before that, let's explain it. Here, sine of x is equal to 0, which gives x is equal to 0, plus minus pi, plus minus 2 pi, plus minus 3 pi, and so on. We can write it in general form as x is equal to n pi, where n is an integer. Therefore, correct option is option A. Question number 24. Tangent of cotangent inverse x is equal to, and the options are. Let's find out which one is the correct option. But before that, let's explain it. A well-known inverse trigonometric identity is cotangent inverse x is equal to tangent inverse 1 over x. So we can write tangent of cotangent inverse x is equal to tangent of tangent inverse 1 over x. Here cotangent inverse x has been replaced by tan inverse 1 over x. Now tan and tan inverse x will cancel the effect of each other, and we get tangent of cotangent inverse x is equal to 1 over x. Therefore, correct option is option B. Question number 25. The range of cosecant inverse x is equal to, and the options are. Let's find out which one is the correct option. But before that, let's explain it. By definition, the range of cosecant inverse x is the closed interval from minus pi by 2 to plus pi by 2 minus the element 0, because the cosecant is undefined at x is equal to 0, because cosecant theta is equal to 1 over sine theta, and if theta is equal to 0, sine of 0 is equal to 0, which is undefined. Therefore, 0 is not included in the range of cosecant inverse x. Therefore, correct option is option C. Question number 26. Tan inverse 3 minus tan inverse minus 2 is equal to, and the options are. Let's find out which one is the correct option. But before that, let's explain it. Here, a is equal to 3, which is positive, and b is equal to minus 2, which is negative. Therefore, the product will be minus 6, which is less than minus 1. So, according to these conditions, tan inverse A minus tan inverse B is equal to pi plus tan inverse A minus B over 1 plus AB. Now, we replace the values of A and B by 3 and minus 2, and we get tan inverse 3 plus minus tan inverse minus 2 is equal to pi plus tan inverse 3 minus minus 2 over 1 plus 3 into minus 2. On simplifying, we get the right hand side to be pi plus tan inverse minus 1. The value of tan inverse minus 1 is minus pi by 4. So we get the answer to be 3 pi by 4. Therefore, correct option is option B. Question number 27. Sine inverse 3x minus 4x cube is equal to, and the options are. Let's find out which one is the correct option. But before that, let's explain it. We put sine inverse x is equal to theta, which gives x is equal to sine of theta. Therefore, the given expression becomes sine inverse 3x minus 4x cube is equal to sine inverse 3 sine theta minus 4 sine cube theta. Here x has been replaced by sine theta in this expression. Now we know that sine of 3 theta is equal to 3 sine theta minus 4 sine cube theta, triple angle identity for the sine function. So we can write the right hand side as sine inverse sine of 3 theta. Sine inverse and sine will cancel the effect of each other and we get 3 theta. Replace the value of theta and we get right hand side to be 3 sine inverse x. Therefore correct option is option D. Question number 28. Which test is used to check whether function is bijective or not? And the options are, let's find out which one is the correct option. According to horizontal line test, a function is bijective if a horizontal line intersects the graph of function exactly once. So the correct option is option B. Question number 29. Which test is used to check whether a binary relation is a function or not? And the options are, let's find out which one is the correct option. But before that, let's explain it. The vertical line test states that if the curve is intersected by a vertical line only once, then the curve is a function. Therefore, the correct option is option A. Question number 30. Cos inverse 2x square minus 1 is equal to, and the options are, let's find out which one is the correct option. But before it, we explain. Let cos inverse x is equal to y and it gives x is equal to cos of y. Therefore, the given expression cos inverse 2x square minus 1 can be written as cos inverse 2 cos square y minus 1. Here, x has been replaced by cos of y. Now, we know that according to double angle identity of cosine function, cos 2y is equal to 2 cos square y minus 1. Therefore, the expression on right hand side can be written as cos inverse cos of 2y. Now cos inverse and cos will cancel out the effect of each other and we get cos inverse of 2x square minus 1 is equal to 2y. Now replace the value of y with cos inverse x and we get cos inverse 2x square minus 1 is equal to 2 cos inverse x. So the correct option is option A.